Welcome back to The Deep Dive. We're the show that takes really complex stuff and boils it down for you. Essential insights, surprising facts. Today, we are plunging right into checkpoint VSX deployments. It's a really powerful way to handle network security using virtualization. And our insights for this one, they come from some pretty intense materials. The kind designed for, top-level security pros aiming to master checkpoint's advanced side. Think of it like getting a peek into the masterclass notes. Our mission today is to unpack the core pieces and advantages of VSX, get you those key takeaways.
Yeah, that's a great way to put it. And while, yes, this stuff comes from, let's say, a deep technical training context, it actually lays out the basics of VSX in a super clear, structured way, which makes it incredibly useful for really anyone wanted to understand how big segmented security setups are managed these days. Because virtualization, I mean, it's not just some buzzword anymore, is it? It's getting really central to modern network defense. It's about understanding that fundamental architecture that lets you build secure environments that can actually scale.
Okay, let's start at the beginning then. The basic building block, the virtual system, or VS. So unpack that for us. What is a virtual system in VSX exactly? And why is it so, fundamental?
Right. So a VS, a virtual system, is basically a complete firewall instance, but it's all virtualized. Imagine a full checkpoint security gateway doing everything a physical one does, but just running in software on the VSX platform. The really crucial part here, the thing that gives it its power, is the independence. Each VS acts like its own distinct security device. It gets its own security policy, its own network interfaces, its own routing tables, its own configurations, totally separate.
Wow, okay. That independence sounds key. So for someone listening, what's the big practical advantage of that? How does it change how you'd think about designing network security?
Well, think about what that really lets you do in your design. Instead of trying to manage one massive complicated policy for absolutely everything, virtual systems let you create these really focused, independent security zones, almost like mini firewalls. You could have one tailored just for finance, completely walled off from, say, your R&D network, but they're all running efficiently on the same physical hardware.
Ah, I see.
That's a totally different way to manage diverse security needs, right? Highly isolated, customized security for each department or tenant or whatever segment you define.
That really clarifies the separation aspect. Okay, so you've got these separate virtual firewalls, but how do you actually get one working to make it start enforcing those rules?
Yeah, that's a super important step, and honestly one that could be missed. For a new virtual system to do anything useful like inspect traffic or enforce rules, you have to install a security policy onto it. And that comes from the security management server. That's the central controller.
The mothership.
Exactly. It pushes out the configurations. Without that policy install, the VS is essentially just inert from a security perspective.
Right.
It can't inspect traffic, can't enforce anything. It's like having a bouncer with no instructions. Useless for security.
Okay, makes perfect sense. So you've got these independent VSs set up, policies loaded. The next logical question is, how does traffic get between them or around them? That's where I assume virtual routers and virtual switches come in. This feels a bit like, segmenting a big company network, maybe finance, HR, R&D needing separation. Doing that with just physical firewalls sounds like a headache. How do these virtual components make it cleaner? And what's the difference between them?
Right, exactly. They play really distinct but complementary roles. It's all about directing traffic correctly in this virtual space. So first, the virtual router, the VR. Think of it as a layer 3 device. Its main job, routing IP traffic between different virtual systems, or maybe between a VS and the outside physical network. But, and this is crucial, the VR itself doesn't apply security policies. It's just focused on efficient IP routing, getting packets from network A to network B.
Got it, just the routing. So what about the virtual switch then?
Okay, so the virtual switch, or VSW, that operates at layer 2. Think Ethernet frames. Its job is to forward traffic within the same broadcast domain, just like a physical switch does on your desk. So if you need devices within the same logical network segment, maybe attached to the same VS to talk to each other, that's the VSW's job.
Ah, okay. So the analogy helps. Virtual router is like the big intersection directing traffic onto different highways, while the virtual switch is like the lanes on one specific highway, keeping traffic flowing smoothly within that highway.
That's a pretty good way to visualize it, yeah.
So fundamentally, virtual router, layer 3 IP routing between networks. Virtual switch, layer 2 frame forwarding within a network. What does knowing that distinction mean practically for someone designing or managing one of these VSX setups?
Oh, it's absolutely critical. Understanding that layer 2 versus layer 3 difference is fundamental to designing, well, efficient and secure virtual networks in VSX. It dictates where you put your security boundaries, how you segment traffic to prevent, bad stuff moving sideways across your network if one segment gets compromised.
Right, controlling that lateral movement.
Exactly. But talking about keeping things flowing smoothly and securely, that brings up another really important point. What happens if one of these complex systems, or maybe the physical hardware it runs on, has an issue? How do you keep the security running?
Yeah, good question. High availability, right?
Precisely. And that leads us straight into virtual system load sharing, VSLS.
Okay, VSLS sounds important for keeping things running. What's the main problem it's designed to solve in a VSX world?
Well, VSLS, virtual system load sharing, it tackles that exact challenge, keeping things running smoothly and being able to handle more traffic, continuous operation and scalability. What it lets you do is distribute your virtual systems across multiple physical VSX gateways, not just one box.
Ah, okay, so not everything's riding on a single piece of hardware.
Exactly. And that's a massive deal for both high availability and performance in these virtual security environments.
So break that down. How does distributing them help? What are the two big wins there for the listener?
Okay, two main advantages. First, you get enhanced performance
How so?
because the traffic load for all those virtual systems can be balanced across the different physical gateways. No single box gets overwhelmed.
Right, spreads the work.
Yep. And second, and maybe even more importantly, you get increased availability, true resilience. If one of your physical VSX gateways fails, hardware issue, maintenance, whatever the virtual system's running on it, can automatically fail over to the other active gateways in the cluster.
Seamlessly.
Ideally, yes, seamless failover. So your security inspection, your traffic flow, it just keeps going, no interruption.
Okay, so VSLS isn't just about making things faster. It's fundamentally about making sure the security doesn't just stop if one box dies. Building in that redundancy.
Yep. You absolutely nailed it. That's the core idea. It's not just a nice-to-have performance boost. VSLS fundamentally tackles single points of failure. It builds resilience right into the architecture. And in any serious enterprise network, that's not optional, right? It's table stakes.
Totally.
A continuous security operation, even if something breaks, that's non-negotiable today. VSLS is a key mechanism to make that happen in VSX.
Right. That makes a lot of sense. We hope this sparks some ideas for you. Think about how these concepts fit into your world, your understanding of network infrastructure. And as always, we encourage you to keep doing your own deep dives. Thanks for joining us.